This video is about ionic compounds, so we're going to review what you've learnt in Year 9 so that hopefully you will be an expert at writing them. So what are ionic compounds? It's all in the name. Ionic compounds contain ions. Usually those ions are metal ions with non-metal ions, but there is one exception. There are ionic compounds that contain only nonmetals, and those are based around ammonium. Because remember, an ammonium ion is NH4+, so these are the only ionic compounds that contain no metals. So let's start by looking at cations. Cations are positive ions, and it's all in the name. If you look at the word cation, it contains a positive sign to remind you that it's a positive charge. This means that you have more protons than electrons. So let's look at how a cation forms. So you've got a sodium atom, and a sodium atom contains 2 electrons in the first shell, 8 in the second, and 1 in the third. This is an unstable electron configuration. So it has 11 protons, 11 electrons, and its electron configuration is 2, 8, 1. It's an unstable electron configuration. So it would prefer to lose an electron. Now, to lose an electron, it actually has to transfer it to something else. Let's look at what happens when it loses an electron. The sodium loses 1 electron and now has an electron configuration of 2, 8, which is now a stable electron configuration, and it's lost that 1 electron. That will actually be transferred to a non-metal. So if you look at it now, it's got 11 protons, but only 10 electrons. So it's a sodium ion, and its electron configuration is 2, 8, which is now a stable electron configuration. Now let's look at anions. Anions, it's all in the name again, are negative ion. So these are negative ions, which means that they have more electrons than protons. So if you look at something like fluorine as an atom, its electron configuration is 2, 7. So it's got 9 protons, 9 electrons, and its electron configuration is 2, 7. This once again is a stable an unstable electron configuration. So it wants to gain an electron, and because it has really high electronegativity, it actually doesn't tend to have much trouble gaining an electron. So this electron comes from something like the sodium, which wanted to lose an electron. So when it gains an electron, you now have an electron configuration of 2, 8, which is now a stable electron configuration. And you can see there it's gained an electron, and its electron configuration is 2, 8, which makes it stable. So how do ionic compounds form? Normally when you have a metal, and remember there is the exception of the ammonium ion, it has a relatively large atomic radius, which means it doesn't hang on to its outer shell electrons very tightly. So it tends to transfer its electron or electrons from the outer shell to a non-metal which has a high electronegativity. Remember, electronegativity means your ability to attract an electron within a bond, and non-metals have really high electronegativity. So an ionic bond forms, and it's an electrostatic attraction between cations and anions arranged in a regular 3-dimensional lattice. So to write formula, what do you need to know? You need need to know your valencies. You need to know what charge each of the ions tends to form. So you need to rote learn these. This will give you your best chance of being able to write a correct formula once you understand how to do that. So let's look at an example. Now we know sodium has got an electron configuration of 2, 8, 1. And chlorine has an electron configuration of 2, 8, 7. So sodium wants to lose an electron, chlorine wants to gain one. So sodium transfers its electron to chlorine, so you end up with sodium having an electron configuration of 2, 8 and being a positive ion, and chlorine becoming chloride and having an electron configuration of 2, 8, 8. Now, you don't want to have to do this every time you do a formula. So what I'm going to show you is some ways of trying to do it so that you don't have to draw shell diagrams. So we know that sodium has a valency of positive. We know that chloride has a valency of negative. We know that all ionic compounds must end up being neutral. They carry no charge. So whatever charges each of the ions have has to come back to 0 because they are neutral. We don't go around being zapped continuously. So this one's a nice easy one. So you've got 1 plus and 1 negative. Add 1 plus to 1 negative, it comes out to 0. Common multiple, by the way, of 1 and 1 is 1. So how many 1 pluses do we need? We need 1. How many 1 negatives do we need? We need 1. So the formula becomes NaCl. Another way of showing it is by using a little number line. Here is our 0. This is where our Na plus sits at 1 plus. And how much do we need to bring it back to 0? We need to have 1 negative. Another way of showing it is swap and drop, but you need to know how that works in order to get the best result. So NaCl is the correct formula. Now let's try another one. This time I'm not going to draw a shell diagram, I'm just going to start with the valencies. So I have learnt that magnesium is Mg2 positive and chloride is Cl1 negative. Now I like to use the common multiple method so that you can work out exactly how many of each is required to come back to 0. So the common multiple between 1 and 2 is 2. So how many 2 pluses do we need to make 2 plus? We need 1. How many 1 negatives do we need to make 2 negative? We need 2. So it becomes MgCl. Let's look at another method. This time we're going to use a number line. So here's our number line. Here is our 0. Here is +1. Here is +2. This is where our magnesium is sitting, at the +2 point. How many 1 negatives do we need to come back to 0? We need 1, 2. So it becomes MgCl2. Third method, swap and drop. Swap and drop, MgCl2. Now let's try another one. This time we're going to try aluminium fluoride. Once again, you have to know your valencies. So this is Al3+, and fluoride is F negative. Common multiple method. Common multiple between 1 and 3 is 3. How many 3 pluses do we need to make 3? We need 1. How many 1 negatives do we need to make 3 negative? We need 3. So it becomes AlF3. Let's try the number line. Al3+, F negative. So here is 0, 1, 2, 3, plus 1, plus 2, plus 3. So this is where our aluminium is residing. How many fluorides do we need which have a charge of -1? 1, 2, 3 to bring it back to 0. Third method, swap and drop. AlF negative. 3 down there, 1 down there, becomes AlF3. Now let's look at magnesium oxide. Magnesium has a charge of N2+, oxide is 2 negative. Common multiple of 2 and 2 is 2. How many 2 pluses do I need to make 2? I need 1. How many 2 negatives do I need to make -2? I need 1. Number line. Here's our 0. Here's our magnesium 2+, and you can see 1 lot of 2 negative brings it back to 0, so MgO. Now watch out for swap and drop here, because this is where swap and drop can become dangerous. 2 to 2, and that is incorrect. So the lowest ratio is 1:1, so be very careful if you're using swap and drop. Now let's try a third example. So we have zinc 2+ and nitrate, which is 1 negative. Common multiple between 2 and 1 is 2. So it becomes, how many zinc 2 pluses do we need? We need 1. How many 1 negatives do we need? And remember, it's the focus on the charge, not this number here, because that number belongs to oxygen. That's telling you how many actual oxygen atoms are in that polyatomic ion. So, how many zinc 2 pluses did we need? We needed 1. How many nitrates do we need to make 2 negative? We need 2. NO3, 2. Now that doesn't look right. It's telling me at the moment that I have 1 nitrogen and 32 oxygen. And that's not true. We actually needed 2 lots of nitrates. So this is when you start to use your brackets. Using the number line method. Here is our number line. +1, +2. Here's where our zinc 2+ is. How many nitrates? Well, each one is 1 negative, 1, 2. So I needed 2 of them. Swap and drop. Swap and drop. Becomes ZnNO3, 2. Don't forget your brackets. Let's try one last one. This time we're looking at ammonium sulfate. So ammonium has a charge of NH4 positive and SO4 2 negative for ammonium sulfate. Common multiple between 1 and 2 is 2. So how many positive 1s do we need to make positive 2? We need 2 of them. Now that's not looking right. 42 hydrogens. I think we need a bracket. How many sulfates do we need to make 2 negative? We only need 1 of them, so it becomes NH4, 2, SO4. Try using the number line. NH4, SO4, 2 negative. Here's our number line. So this is where our ammonium is currently sitting. If if I add one lot of sulfate, 1, 2, that takes us back to -1. So that can't be right because it has to have no charge. So let's put a second ammonium in. We'll rub out our first attempt. So now if we add our sulfate, which is -2, you can see it brings it back to 0. So we need 2 ammoniums and 1 sulfate. Swap and drop. So swap and drop, 2 goes there, 1 goes there, NH4, 2. Once again, I need my brackets, SO4. The only way you're going to get good at this is to try some for yourself, so make sure you go to your OneNote and try some. Remember, the key points to remember here is number 1, you need to know your valencies. You can't survive without them, so please go ahead and learn them. And the second thing is ionic compounds charges must add to 0 because no compound carries a charge. Good luck.